Hello there and welcome to this presentation. I'm very glad that you've been able to join us. So this presentation, we are going to look into simulation and virtual labs in teaching science subjects in secondary school. Okay, so, and obviously not just secondary school, other higher level schools, all right? So the platform we are going to use is the Lab Exchange platform. You can see it here. You access it by opening your browser and going to labexchange.org. It's a platform that actually mesh all other simulations and virtual lab platforms together. Okay, so when you search that on your browser, you see the homepage, and it's actually made available by Harvard Online. Okay, they offer educational resources from 175 leading organizations. So that's not what we are looking into here. We are going to look at how it works, and we know that it engages a community of educators and learners and mentors. I'm happy and privileged to be part of this community, and I've contributed to the site. All right, so let's get started. How do we use this? You go to labexchange.org, all right, and I will suggest you sign up, but you can still use it without signing up. And if you have signed up, you can log in and you start using it. But when you get to the home page, you come here and you select the subject. Okay, so when you click on subject, okay, they show you there that they have free resources for everyone. You can see biology, chemistry, physics, earth and space, and you can join a class or a curricula. And okay, and since I'm a physics teacher, let me start with demonstrating a simple experiment, simulated experiment, okay, on refraction. I noticed that this is one of the abstract topics. When you actually teach the student, you see they find it difficult to understand. But now imagine if you can be showing this to them on maybe a smart TV in their lab, or maybe a projector, or maybe your laptop or your smartphones, even though that will not work for a large number of students. Okay, so let's quickly, for instance, I want to teach refraction, okay, which is actually the bending of light as it is passing through different media. This is actually a simulation that I've already opened to save time, so that I'll make this video short as possible. So the introduction here, you see, you can actually, for those of us that are teaching physics, you can actually move around the apparatus. This is the protractor that you use to measure during the experiments of refraction. Now light is passing from air to another medium which is denser, which is like it could be air to air, it could be air to water, it could be to glass. So I'm using glass because this is in the curriculum that we are using for physics currently in secondary schools. So now you see I can easily move my protractor, incidence ray of light. So now I can now say, okay, I want to conduct an experiment in which the light is incident at 60 degrees. All right. And now I can see that the refracted ray is about 32 degrees. If you conduct this experiment with a glass which has a refractive index of about 1.51, you get a result that is this way or something close to this. Okay, so there are other topics. You can see in physics, I've made use of projectors to even teach my students. I've made use of this simulation actually in class before, but it was difficult having to be moving my laptops around and my mobile device around. It was difficult. That can lead to maybe the device being spoiled. Okay, but just what I want to show you is how it could be done. For those of us teaching physics, you can see it gives other options for that prism, like our triangular prism, and you can use to demonstrate refraction. You see, you can even demonstrate it with different beams of light, and of course you can change the background of the experiment to make it very much engaging. it's very interesting to know that this can actually simplify the whole idea of teaching physics. Most of the abstract concepts have some simulations and experiments that you can just demonstrate for the student to see. Okay, so that's it. You see, we can use a ray of light here, and we can as well use waves to demonstrate this. Okay, very interesting. Now, if we go to biology, okay, that's chemistry. I actually explored this simulation in which we are talking about forming a molecule, how molecules is formed, forces on molecules as they are brought together. Okay, so this simulation is you should move the atom closer together and observe how the forces of the atoms field change based on the position of the atoms. We all know that if you at high level bombardment, if you bring molecules together, it's as if the force of attraction becomes high, but when you bring it so much close, it becomes a repulsive force. So overall interaction here is repulsive, but when they are further a bit apart, it's more of an attractive force. If you now bring molecules together, you force it together. When they are so close, it becomes repulsive. So this can simplify the whole idea of quantum physics and quantum mechanics, and even in chemistry, explanation of forces and bonding. Okay, so I'll encourage all chemistry teachers to explore all other simulations available. Okay, in a subject like biology, I had some fun exploring this simulation of the cell structure. The simulation was to help students to be identifying the parts. Okay, they say identify cytosol. Okay, now if I go and identify something that is not it takes you back to your original score again, and it's asking you to identify rough endoplasmic reticulum. If I come here and identify the correct one, it gives me the score and take me to the next one. You see how interactive it is for the students. So if students can be exposed to this, they learn as they interact with it. And even a more difficult concept like DNA to look at the structure. This is just one of the simulations available. You can use this simulation to explain the structure of DNA to the student. You can actually play around with it here now. This is showing the hydrogen bond. It's showing the strands. It's showing the strands 1 and strand 2. If I want to take out the atoms from the simulation now, you see, if I want to take out the space fill atoms here, I can just click here now. Let's see how that goes. Okay, you notice it's more of interactive. You can rotate and explain the shape of this to the student. I really had fun exploring this. There are other simulations that you can use on this platform. Okay, and also you can contribute to this platform by creating pathways. Okay, and that is if you've joined their training sessions and you are part of the community, of which if I'll be sending updates when such opportunity comes. Okay, so basically this is just a video to show you how to actually use these simulations, and as a science teacher I'll encourage you to explore these platforms and see how you can make use of this in your classroom. Feel free to drop your questions and I'll be there to answer it on our training group or on the description of this video, on the comment sections of this video. Thank you very much for watching. Have fun. I hope you apply this knowledge in your classroom to make your learning more interesting. Okay.